Hi, my name is Pete Wood. I'm going to talk today about how we use Grafana Cloud around our air quality and activist engineering program at DesignSpark. So a little bit more about myself. I have been in the electronics and semiconductor industry for about 25 years. I've been in technical sales, applications and marketing. And over the last 10 years, I've been involved in some pretty cool projects and products with RS Components. Everything from working with an innovator like Richard Browning, who's created a rocket suit, you might have seen him on the TV, to putting a Superman action figure into space for Mattel Toys, and building a 3D printed boat with a bunch of engineers to try and sell that across the ocean and get a world record. So some pretty cool things over the last few years. And that is now continuing with some of the projects we're doing moving forward, including the one we're going to talk about today. So if we look at DesignSpark and who we are, so as I mentioned before, DesignSpark is part of the RS Components group. If you're an engineer, you most likely would have heard of us. We supply components and products to engineers around the world. The DesignSpark platform is 12 years old this year. We are a global engineering platform which has 1.2 million members, and we offer software CAD tools, technical resources. We work with the world's leading suppliers to position their products and technologies to basically help inspire and enable design engineers to create awesome products. We are one of the world's largest engineering communities, and our recent journey is now all about how we look at championing what we call activist engineering. And this is all about engineering responsibility. So when we look at that, if you think about engineers, how can we help those engineers create engineering outcomes that are positive when they impact the world around us? So our kind of position on this is like, we have got these 1.2 million engineers in our community with 10,000 new members coming into the platform every month. How do we help educate, influence, promote and enable those design engineers to think and design more sustainably, ultimately, to become a more responsible design engineer? So together as a collective, we can unite and we can build this kind of movement, if you like, of activist engineers. So the first part of our journey with activist engineering is around air quality. So what we wanted to do to kind of raise the awareness of the activist engineering program was create a project which sort of had a community-driven element to it. So how could we unite the community with the goal of sharing back the data and their experiences and projects and applications that they've done around this subject. So what we have done is we've looked at air quality from an indoor perspective, first of all. So unbelievably, actually, air quality indoor is almost as bad for you as the outdoor air quality. A lot of people don't realize that, and we'll come to a bit more about that in a minute. But I was actually really I couldn't believe that 1 in 5 deaths worldwide, they're saying, is responsible, air quality is responsible for the deaths of 1 in 5 people. And in terms of, look at London alone, where I'm here, 99% of the air, apparently, according to the World Health Organization, is unfit to breathe. So that's a pretty big problem. Next step we did, so we've got this idea of enabling the community to have this air quality drive. The next thing we wanted to do is create some hardware, so the tool that they could use in order to do that. So I've got one here. This is the same as what's on the screen. This is basically an open source kit that we've designed. We've used our DesignSpark tools to do it. It's based on a Raspberry Pi. We've shared all the CAD and the code on our GitHub. And, the sensors aren't calibrated on it. It's very much around trends rather than accuracy. And, it's a tool to help drive that positive action. So how, we can give these to engineers to put in their environments and discover the challenges that they've got in order to try and then solve the problem. So whether that be using technology, or whether they would, challenge authorities, or whether they just be as simple as open a window. There's lots to do on that front. So taking a bit of a deeper look into the sensor kit itself, as I say, it's been designed around a Raspberry Pi, and it's got a touch screen on it. All of the sensors are from a company called Sensorium. They're not calibrated, as I said before, and I say this is all about the trend rather than the accurate data. But what it ultimately allows you to do is to track the key things that affect air quality. So that is the particulates, and that comes in various forms. We all know about particulates outside, from traffic pollution, etc. But there are other things in a household like cooking, dust, smoke from your open fire or your wood burning stove, for example. All of those have an impact on your health. You've got VOCs, volatile organic compounds. Those come from aerosols. And if you've got a 3D printer in your bedroom or at home and you haven't opened the window properly, all the particulates come off that are pretty nasty for you. And then there's the simple things like CO2, and CO2 isn't necessarily going to kill you, but actually CO2 in terms of your creativity and your cognitive kind of reaction, you start to feel tired and unproductive when you haven't got when you've got high levels of CO2 in your room. So that's interesting. And also it's been in the news a lot recently around COVID. So the more CO2 in a room, the more likely COVID particles are going to be hanging around. So that's a really quite interesting thing as well. So this development kit is something that we produced for a bunch of beta users, and we'll come to that in a minute. And it's an enabler, as I say, for them to start looking at how they can become an activist engineer. So the first thing we did, which was really cool, was we thought we'd go and find a bunch of project influencers, if you like. So we gave our kits to 12, actually it was, we've got 6 here, but we gave this kit to 12 influencers around the world, and we asked them to build us some really, really cool projects that would use our ESDK kit. And then we wanted them to share their stories and their data back to us, and that would inspire the rest of the community to come and take part in the next phase. So we've got everything from, on the left here, so Jude Pullin, who was a key part of the project with us, he created his CO2 canary. I think we've all heard of the canary in the coal mine concept, and this is around the canary detecting CO2 levels. So it uses MQTT from the Raspberry Pi enabled ESDK kit there, and that talks directly to canary, and as the CO2 levels climb up, the canary starts to react accordingly. So eventually, if you don't open the window and let the air in, the canary falls off its perch and dies, right? And then when it's better again and the air is back to normal, the canary comes back up, and it says all kinds of cool things in between. So you can see that on our YouTube channel. That's really fun on that. Then you've got the more serious ones like Michael. So Michael is doing an amazing project that's truly an activist engineering project. There was a young girl in 2013 in London. Her name was Ella. And I think she was the first person in the UK to have her death down to the excess levels of pollution in her lungs. So this is a rising problem in our towns and cities. What Michael wants to do, working alongside Ella's family, is how can he build awareness of problems around schools in terms of pollution. And a lot of this is around vehicles. So how do you get the parents to change their driving habits, or anyone who uses the road system around schools? And he's building this thing called the Mindful Droid that kind of monitors your driving habits. So you're not heavy footed on your accelerator, and you're not taking routes maybe that take you too close to schools, and you're producing particulates that aren't good for the children that are walking around there. So that is a really, really cool project that is still under development. You've got projects like Cecilia, who is using her Good Air Bear to track forest fires. And hers is really cool because hers uses an API from the Weather Service as well as local data from the sensor to detect if there's smoke, so it can warn you to come and close your windows. Ahmed's got a really cool project in Nigeria where he's doing a community-led project where he's basically alerting the locals to the air quality in the streets around them so that they can see that. Geeky Faye has built an amazing project around passive smoking. The necklace she has detects smoke, and when it detects smoke, it basically glows, so you know to walk away. And Snoof has done a brilliant project. If you suffer from allergies, especially hay fever, she's got a pollen tracker that connects to an API, and the API goes into her little castle of flowers here. And when you've got symptoms, when you wake up in the morning, you can go and squeeze the flowers, and then that starts using AI to correlate when your symptoms are bad compared to the levels of pollen that are in the air. So that's a really cool project as well. So those projects we used to start driving the kind of inspiration behind what we were doing around air quality and get the next level of interest coming in. So what we needed was a cloud platform. So this is where Grafana comes in. So we're collecting all this data and we're doing all these amazing projects, but we wanted to do something with that data. We want to be able to collect and visualize and potentially use that data for anyone who wanted it. Again, remembering it's not super accurate data, right? So the requirements for us basically were, we needed something that we could get up and running very, very quickly. So this was very much a proof of concept project for us at this point. We were experimenting. We were, it wasn't something the kit we were going to mass produce. We wanted to see how this would work, and we could put something very quickly together, if you like. So not only did we need it quick time to set up, but we needed something that was low cost and value for money. So it was a low barrier of entry for us and easy to get signed off by the management. It needed to be flexible and portable with some scalability. So we wanted to do some work with it and not have to chuck it away afterwards. So potentially something we could pick up and move somewhere else if we needed to. And from a scalability point of view, okay, we had 12 users today and the 50 users will come on to a minute. But actually, we wanted to have a platform that allowed us to go from that 12 or that 50 up to thousands of users potentially. So that was a really important factor for us. We also wanted it to support many types of data sources. Our AESD kit was just with only one, but we were looking at how we might bring in other platforms and solutions as well. We needed a time series database, basically. So we wanted to be able to scrape that data through the time series database so it could be chronologically ordered. We wanted professional visualization. I think for me, that was one of the key things that really, really attracted us is like, how can we visualize that data in a really neat way that grabs people's attention rather than just showing basic graphs or just reams of data? How do we get something that allows us to show that in a really, really awesome way? We needed it to be secure, right? So both from a private perspective, so people were obviously showing their private data that's coming up, but we also wanted the ability to have public dashboards. So we want to be able to take the data that was collected privately and then scrape that out somehow to visualize that as a community level. So, in some ways it was anonymizing the data, if you like. We wanted to be able to do that. Multiple devices per user. So rather than just one device per user, we wanted to have multiple devices connected up per user. So you could, in this case, have lots of ESDK kits dotted around the place, and they could all connect up to the same cloud platform in terms of your own private dashboards. And we needed tech support as well. So we hadn't really done anything like this before. We are working with third party, AB Open, who's helped us do this, but we needed some tech support as well from the partner that we chose. So ultimately what we found was there was nothing off the shelf for us. We looked at off the shelf solutions and it didn't give us what we wanted. We needed something that was a bit more bespoke, hence why we went out and looked. So this is where Grafana came in. So we discovered Grafana and it pretty much gave us everything that we needed. So it gave us this hosted Grafana plus Prometheus database, which was the ideal solution for us. It was fully managed with the first class development tech support, which we really, really needed to get up and running quickly. It allowed us to have all these additional features that we needed to help deliver those requirements. And in terms of implementation, it allowed us to bring in this, we used OpenID to connect the integration between the Okta identity management system we use. So Okta we use basically to help authenticate the users, and we were relatively seamless in integrating that into the platform. So that worked really, really well. And we needed somewhere obviously where we could, store the sensor data, and Design Spark based on the Grafana platform allowed us to use that Prometheus database to store that data and visualize that data. So that's why Grafana, turned out to be the best solution for us. And then if we look at roughly how it works, we've got this managed service by the Grafana Cloud using this API for provisioning and administration. So basically, we're using these custom scripts to automate the provision of the Design Spark users we spoke about just on the last slide. And if you look at the kit, we're running Python on the platform because it's Raspberry Pi based, and we used remote write, which is the mechanism we use to write up through to the Prometheus database. So we've got remote write into Prometheus, we go to PromQL, and then that gives us all the data into these dashboards, which are very customizable. That was the other great thing about Grafana. We were able to kind of customize how we wanted it to look. There's a lot more we've got to drill down into the detail, but very quickly you could visualize things in a simple way with your graphs, your line graphs and your bar graphs, and then there's all these other modules you can drag and bring in. There's the limit is probably your imagination, as they say, right? There's so much you can do with this platform, but right now, we're at the very basic part of it, and we're just only starting to looking at the public dashboard element now, because that's the bit more of the complicated bit. How do you display public data in a meaningful way? And that's the bit we're kind of looking at now. So bit of fun, I guess, when we started messing about with the dashboards. This is me cooking my breakfast on Sunday morning, and this is about showing how particulates when cooking can be really, really bad, right? So taking bacon, for example, I've got here death by bacon sandwich. Not only is bacon full of fat and salt and that, but actually the cooking process is just as bad for you. So if you look here, 8:22 a.m., I put the bacon on and you've got relatively normal levels of CO2 and VOCs and particulates, the PMs. As soon as I start frying, and you can see here on the graphs on the right, everything starts to go up. Temperature goes up, humidity goes up, obviously the temperature, but the VOCs and the CO2 and all of the PMs start to spike, and they're throwing all those particulates up into the air. So if you're not especially using ventilation, so you should really have a fan over your cooking hob, and you should open the window really as well. Even with that, you're still throwing loads of particulates in the air. So if you look just after, what was that, 7 minutes or so of cooking, we've gone from normal levels, which, for example, if you look at the PM 2.5s, we have gone from what should be 0.5 up to 1707 parts per million, parts per billion. It's probably, I think, anyway, a lot, right? Really, really bad. Same with VOCs, normal should be 250, and all of a sudden you're chucking up all these things. And that's come from the gas cooking bit. That's come from all the stuff that's thrown out of the pan from cooking the bacon and the grease and everything going in the air. So that's just a really interesting way, again, of me capturing that data locally on my ESDK, but then recording and sending that data up through the Prometheus database and then displaying it on the screen, which I've now got a record of, and I can keep monitor of that, right? Which is really, really cool. So the next bit we're going to do now is we're opening up our experiment to 50 users on the platform on Design Spark. So we've asked 50 users to write into us and say, I'd like one of your ESDK kits because I'm going to deploy it in such and such an application, and I'm going to then measure the air quality at my home or my work, or I think we had some guy who's putting in a cave, to monitor the situation in terms of the air quality, understand the problem that they've got and what's causing it, and then doing something about it. And that's the activist piece. Quite often that might be as simple as, say, opening a window, or it might be that, you live next to a busy road and the bedroom where you sleep is just, there's big trucks going past and you've got all the particulates coming in. You might want to start lobbying your government to say, hey, look, you're killing me slowly because of all the trucks and that going past my house. Or you might design something from a technical point of view. So there might be something you design in order to help solve that problem. So that's what we've asked them to do. We've given out our 50 kits now. We've enabled them all with a cloud connection, and many of them now are starting to deploy and share the data into their private clouds. And the next step for us is to now get that into the public domain. So, for example, I think we had about 10 hack spaces or maker spaces from around the world. So we're going to create a league table in the Grafana dashboard for all the hack spaces around the world. And then we're going to gamify it and get them all to compete to see who is the cleanest air in the hack space. So that'll be really interesting when that comes out. And we should be doing that hopefully in the next sort of month or so. So that's where we are. And the next step is to get those betas to write back and share their stories. So keep an eye out on our platform, designspot.com. You can read their journey and look at their data in the Grafana Cloud in the public environment. And at some point, you might even be able to take part if we release another set of kits. So that is us. So thank you for listening today. I say the Grafana platform has been brilliant at bringing our project to life. It enabled us to do it very, very quickly in a professional looking way. And it's super flexible. So I know we're only scratching the surface of the capabilities of the platform. Please come and check out designspot.com. We're a free platform. We've got content, we've got project material, and we've got amazing things for you to follow. We have a newsletter, and as well, follow us on the social channels as well. So thank you very much, and see you soon.